What if I told you every single star you see in the night sky is actually a massive nuclear reactor burning for millions, even billions of years, from tiny red dwarfs to giant blue superstars? Today, we're diving deep into the secret life cycle of stars, how they produce energy, their colors, their sizes, and the powerful science behind the Hertzsprung-Russell diagram. By the end of this video, you'll never look at the night sky the same way again. Stars are gigantic balls of hot gas, mainly made up of hydrogen and helium. Inside a star's core, something incredible happens. Hydrogen atoms combine together through a process called nuclear fusion. This fusion creates massive heat, bright light, and energy that travels across space. And guess what? Our sun is also a star, continuously converting hydrogen into helium and releasing energy for over 4.5 billion years. This energy is what makes life possible on Earth. Inside the core of a star, the temperature reaches millions of degrees Celsius, and the pressure becomes extremely high. These conditions force hydrogen nuclei to collide and fuse together to form helium. During this process, some mass is lost, and according to Einstein's famous equation E equals mc squared, that lost mass is converted into energy. This energy slowly travels from the core to the surface of the star and is finally released into space as light, heat, and radiation. That's actually the glow you see from millions of kilometers away. Have you ever noticed? Some stars look blue, white, yellow, or red. But why? The color of a star depends on its surface temperature. Blue stars are the hottest and are usually massive stars. White stars are hot and are often young stars. Yellow stars, like our sun, are medium in temperature. Red stars are the coolest and are called red giants. Blue stars can be over 30,000 degrees Celsius, while red stars may be around 3,000 degrees Celsius. So, the next time you see a blue star, remember, it's extremely hot. When light from a star passes through a prism, it splits into a spectrum, like a rainbow. But here's where it gets interesting. Dark lines appear in this spectrum. These are called absorption lines. Each line represents a specific element present in the star's atmosphere. For example, you'll find hydrogen, helium, sodium, and calcium. By studying these lines, scientists can identify elements inside stars, determine their temperature, and measure star composition. This technique is known as spectroscopy. Basically, we can understand what stars are made of, without ever visiting them. Now comes the most powerful tool in astronomy, the Hertzsprung-Russell diagram, or simply the HR diagram. This graph compares star luminosity, which is brightness, and surface temperature. When stars are plotted on this diagram, they form groups like main sequence stars. Most stars, including our sun, fall here. These stars are actively fusing hydrogen into helium. Then there are red giants. These stars are cooler, very large, and extremely bright. They are in the later stage of their life cycle. And of course, white dwarfs. These are small, very hot, and less bright. They represent the final stage of smaller stars. So basically, the HR diagram helps scientists understand star age, evolution, and life cycle, all from just brightness and temperature. Stars are more than just twinkling lights in the night sky. They are cosmic factories producing energy, elements, and even shaping galaxies. From nuclear fusion in their cores to spectral lines revealing their secrets, and the HR diagram mapping their entire life cycle. Every star has a story. If you want to stay ahead in science, space, and the future of the universe, make sure to subscribe to Think New, because the next big discovery might be just one video away.